Hey everyone, welcome to the show. You are listening to the Cyber Riddler, a podcast that we talk about the offensive and defensive side of the cyber world. I'm your host, Ahmed Mrabi. This episode is a little bit different because usually we talk about offensive, either about offensive or defensive side. We usually we introduce some cool techniques with our guests. Sometimes we give you some activity or some things that you can use in your next engagements. But this episode will be a little bit different because today we'll be talking about security research or vulnerability research. Something that you can use and you can when you want to find a bug, how you're going to start the research, and what are the steps needed to conduct your research. I will give you stories about some CVEs in the past. And today's guest is someone that whose work I really admire. As a matter of fact, I implemented one of his code or vulnerabilities 2 years ago. We'll cover that, of course. But he's one of the people that I wanted to interview a long time ago. But it's good that we are having him on the show. So I want to introduce Kevin Backhouse to the show. So welcome, Kevin.
Hi there. Yeah, thanks for inviting me.
You're welcome. So, can you, before we start, to be honest, you find really good bugs, and things like in your last discovery, you found SSH. I think in the library libSSH and these things. We'll go that in depth. We'll go that in depth. But I wanted to start by please introduce yourself to the public.
Okay. So my name's Kevin Backhouse. You can call me Kev. I work for GitHub. I work in a team called GitHub Security Lab. And I actually manage a sub-team within the GitHub Security Lab that does security research. I guess I've been in the tech industry since 2002. And for a long time, I was just a regular developer. And I got into security research in 2017, and kind of by accident, but I really enjoy it, and so that's what I've been doing ever since.
So you started InfoSec or cybersecurity research from 2017, is that correct?
That's right. Yeah, that's when I got started in it.
So what happened there? So you were a software developer. So as I recall, you were a software engineer.
That's right. Yeah. So I'd been a regular software developer for a long time. And in 2015, I joined this startup called Semel. And I wasn't one of the founders. I joined several years after the startup already existed. But Semel is the company that created CodeQL, which is now part of GitHub's code scanning product. I guess it was in 2017 that we kind of, as a company, sort of pivoted and realized that CodeQL had a lot of potential as a tool for finding security vulnerabilities, and so it was in 2017 that Uche de Moor, who is the CEO of Semel, asked me and my colleague Mo if we'd be interested in forming a sort of a small security research team. And so that's how I got started. And so what we were doing is we were using CodeQL to look for security vulnerabilities. And so that's how I got started on it. And then I guess 2 years later, Semel was acquired by GitHub. And that's when GitHub Security Lab was created, and Mo and I both became members of GitHub Security Lab, but it's grown a lot. I mean, there were already a few more people involved in the security research at Semel at the time, and then since then the team has grown even more.
So that was in 2018-19, or it was in the 17, the same year that you started the cybersecurity research?
2019 is when Semel was acquired by GitHub, and that's when the GitHub Security Lab was created as well.
Okay, so can you tell us more about GitHub Security Lab? Since you were there from 2019, so I think you guys have a lot of things interesting things, to be honest, that till now that you worked on.
Yeah, so I mean, so the mission of GitHub Security Lab is to improve open source security. And so we're a little bit independent from the rest of GitHub security because it's not our job to secure GitHub itself. We're trying to help open source maintainers secure their code. And so I guess there's a few different things that Security Lab does. One of the really big ones, and this is a different sub team than what I'm on, is the sub team that's called the advisory curation team. So if you're an open source maintainer, then and a vulnerability is found in your project, then you can create a security advisory on GitHub and request a CVE from GitHub. And it's the advisory team are the ones who assign the CVE to you. And they also will write up a kind of a summary of the vulnerability and publish it in the GitHub advisory database, and that also then gets shared with other CVE databases.
Before sorry,
Yeah,
before you go on. So when you say open source maintainers, so are you referring to the anyone who's putting his or her project on GitHub? So if, for example, if there is
yeah.
someone who, for example, if I have a project and I put it on GitHub, and someone else found the vulnerability in this project, he can report it to you guys, or is it like I have to report it to the original developer, or is this what you are referring
talk
to?
directly to the maintainer. So there's somebody who has a project on GitHub, and then somebody else finds a vulnerability in it, and then those two people communicate with each other. So we're not involved in that. We don't get involved in that until the maintainer creates an advisory using GitHub Security Advisory feature,
And
and then they can request a CVE from us.
so the CVE will be requested from you guys, but you will not be. So as a researcher, I will not be contacting you directly. Is that correct?
That's correct. Yeah, no, you would talk to the maintainer of the open source project.
Okay, okay. So this is one of the things you do, and I think you run the code QL you told me about.
Yeah, so the other things that the Security Lab does is we do our own security research, and there's kind of two ways that we're doing that. One is we're running CodeQL queries over thousands of open source projects looking for common vulnerability patterns, and that's my colleague Alvaro runs a team that does that. And then my sub team, we do security research where we're looking at specific code bases and kind of taking a deeper dive into specific code bases. So like Mo, for example, now is primarily focused on Android and Chrome. And so he's studied those two code bases and is finding really subtle bugs in those two code bases. And then the final thing that we do is developer advocacy. So, I mean, we're really trying to be, as a security team, we're actually trying to be on the side of maintainers, helping maintainers to make their projects more secure. So rather than having a kind of an antagonistic relationship, which is the way that a lot of the time with security research, it ends up being quite antagonistic between the researchers and the vendors. But we're really, as a team, trying to help with open source security. So we're trying to have a kind of positive relationship with the maintainers. And so some of the stuff that we're doing is putting out things like blog posts and conference talks where we're trying to advise people on how to write more secure code.
And because when I was looking and going through the GitHub Security Lab blogs and stuff, I found a really let me say odd vulnerability is about an I think insecure random number generator in SSH key pair.
Oh right, yeah. And actually, that's something I forgot to say is that,
It's
like,
a,
one of the other things that sometimes happens with the security lab is that we just people just come to us for advice, and so that one that you're referring to, what happened there was that there's this product called GitKraken, which is a desktop application that allows you to interact with GitHub and other sort of Git hosting services like Bitbucket and so on. And one of the features of this product is it allows you to create SSH keys, and I think it was able to automatically upload the SSH keys that it created to your account on GitHub or Bitbucket or whatever. And somebody at GitKraken had discovered that they were generating quite low quality SSH keys. So it turns out that they were using an open source library called KeyPair, which is a JavaScript library, to generate the SSH keys, which they were then uploading to the service like GitHub. And there was a subtle bug in this code that meant that the quality of the SSH keys was very, very low. And so you're into sort of cryptography, right? Like that's one of your
Yes.
interests, yeah. So I mean, there was two problems. One of which was kind of like not great, but it was a minor problem, which is they were using a pseudo random number generator to generate the randomness that would
What create
be
the
used
key?
to generate
Yeah.
this. But
What create the what it will create the key? So it's the the seeds for it.
yeah, exactly. Yeah. So the source of randomness that was then used to generate the like the RSA key. But the second problem, which was far worse, which was that the they used a function called string dot from charcode and accidentally applied this function twice to the incoming bytes. And the consequence of that was that this byte stream that came from the pseudo-random number generator, something like 99% of those bytes were actually getting converted to zero. And only a very small number of the bytes was getting through as a non-zero number. And so it's quite a nasty bug, because what it meant was that the SSH keys that it generated did look to the human eye random. But in fact, they
It's
if you were to
predictable.
generate a few thousand of them, you'd start seeing collisions in the SSH keys. You'd start to see the same SSH key being generated multiple times after a few thousand iterations. So in fact, these SSH keys were very, very low quality, but nobody had noticed, because if you just hand generate, say, 10 of them, then they look like legitimate SSH keys. And so GitKraken discovered this problem and then actually contacted me, because I guess I'm sort of relatively visible and I have like my email address is published on my GitHub profile and so on. So they actually contacted me, and what they really needed primarily from me was, or from GitHub, was they wanted to have these SSH keys revoked. So they wanted to warn all of the users that might have one of these insecure SSH keys that they needed to generate a new SSH key. And so I then passed this on to my colleagues in the rest of the GitHub security department. And actually it was quite amazing to see, because this was the first time I'd been involved in an incident like this at GitHub. And like very quickly, like a very big team at GitHub got ramped up in order to deal with this thing. And there were a number of moving parts involved. And I guess my main involvement in the whole thing was to communicate with the maintainer of the open source project, because we needed to do a coordinated disclosure, because this affected not just GitHub but also other providers like Bitbucket and Azure DevOps and all the other Git hosting services. And so that needed to be coordinated, and also needed to be coordinated with the maintainer of the open source project, so that it got fixed in the open source project at the same time that it was disclosed to everybody else. And so that was the bit that I did, was communicating with the open source maintainer. But I mean, we had people at GitHub who were analyzing logs so that they could try and figure out which SS keys actually came from GitKraken and might therefore be vulnerable. We also had people generating a big database of potential SSH keys, so we could just search for ones that might be duplicates of what was generated by this thing. So it was quite a big operation. It was really, really fascinating to be involved in.
Usually, when I remember we did an episode about PRNGs, pseudo random number generators. I think it's episode 4 or 5. I do recall,
Hmm.
but usually when there is a problem with the generator itself or the with the function, either if there is a little bit of entropy to the function or there is no enough seeds, usually you will end up with repetitive numbers or numbers that could be predicted even in future states. So usually that may be what happened in the SH keys. That's why you have low quality SH keys because of the random number generator. It was insecure basically. And I want to emphasize something here. Even I think Kevin here you could um, say this as well, that most of the time in security or cryptography in particular, usually we see things in rubbish, like we saw some uh, random number and then we think it's totally random, and we try to generate one time, third time, four round, 5 rounds of the same number, and every time we find a new output and we think that this output is random, totally random, which in reality is not, just a fallacy. You think it's random, but if you run it multiple times, maybe you will end up having the same number over and over again, and that would be insecure from a cryptographic standpoint. So I wanted to emphasize this because what you just said about having low quality SSH keys, usually it could not be discovered by the pair eyes. Like if you want to see it, you'll think that it's secure, but
Yeah,
in
you
reality it's
definitely had
not.
to generate a few thousand of these keys before you started seeing collisions. So just sort of eyeballing it by hand was not a good enough
Exactly.
test to check that the keys were legit.
Exactly. So if I want to say, like, if is there like a prerequisite for research of doing security research? Is there like a difference between a bug or vulnerability research? What's your thought about that?
So yeah, I mean, from my background as a developer, to me, it's all just bugs. And so really the only difference between a regular bug and a security vulnerability is whether or not the bug can be triggered by a malicious attacker. And so what we're interested in is bugs that can be triggered via something that we consider to be the attack surface of the application. That's when it then becomes an interesting security vulnerability. And so that's what we're looking for. I mean, at least that's how the way I see it. I'm just looking for bugs, and I'm just focusing on stuff that I think is accessible through an interesting attack surface.
So the cool thing about you, Kev, that you worked as a software engineer for 15 years. So that's what gave you all of this insights. Because I always say working as a developer is something that it will give you like the upper hand when it comes to security, because you know the developer where the developer will be struggling in his code, like in the authentication, you know that maybe he will be doing this or that, and that's what you can speculate, that maybe there is a bug in there. You know, when the developer want to do, like, use a fancy concept like doing linked list, I want to use a recursion, I want to do all of these cool techniques, but he doesn't know that there is consequences to his things from a security standpoint, and that's what cybersecurity researcher who cybersecurity the developers who didn't get into security, they don't know about these things. So if I
Yeah,
yeah,
that's right.
go ahead.
And actually, I mean, when I was a developer, right, I actually spent a lot of time debugging. Right, I actually,
You worked on
I guess
compilers,
it was
right?
kind of my speciality. I didn't realize it at the time, but I spent a lot of time uh, just fixing bugs and sort of um, analyzing things that weren't working to figure out what was wrong. And so I didn't realize I was setting myself up for a career in cybersecurity, but turns out
Uh,
that was what I was doing.
and you worked with compilers a lot, is that correct?
That's right. Yeah. So that was, and that's also, I guess, how I got into SEML, because a lot of what there's quite a close connection between how CodeQL works under the hood and what a compiler does. So I guess that's how I had this sort of accidental career transition is through my background in compilers, ending up working for SEML, and then from that getting into security research.
That's very nice. So, what is the best way to look for a security vulnerability?
There's a few ways. I mean, the thing that I do a lot is actually just manual audit. So basically reading the code. I spend a lot of time just stepping through the code in a debugger, trying to understand how it works, just getting kind of a mental model of how the application is structured. And the more you get to know an application, the more you start to see inconsistencies, and you start having ideas for where there might be bugs in it. But other techniques, I mean, static analysis is a good one. So, I mean, CodeQL, obviously, but also just things like compiler warnings. I mean, sometimes if you have a file that when you compile it generates tons and tons of compiler warnings, and that's actually a pretty good indication that that file is kind of low quality and might be worth looking at more closely to see if there's any bugs in it. Fuzzing is a big one. Typically, I mean, if you've got an application that's never been fuzzed and you let a fuzzer loose on it, it's usually just total carnage. I mean, the amount of bugs that fuzzers can find is often just incredible when it's never been fuzzed before. And I guess the final one, and this is kind of depressing how often this has actually happened to me, but just finding bugs through luck. So there's been quite a few times when I found a security vulnerability because I've basically just been using my computer and maybe doing something slightly weird with it, and something's crashed. And then I've gone to kind of investigate what happened. Why did this thing crash? And it turns out it's actually a security vulnerability that is potentially exploitable. So I kind of wish it wasn't the case that so many of these security vulnerabilities are still getting found by luck. I'd like it to be more of a repeatable process, but that's certainly the way it seems to be still a lot of the time.
You know, sometimes when you try to find a vulnerability, when you do fuzzing, it's something that you will just run your fuzzer and you will finger cross that something will turn out. And sometimes I don't think you just fuzz it, but you don't know if this application will give you any error, or there is the false, or there is a fatal error coming out from it. So you will just finger cross and you go on. But luck, turn out to be something is very nice, because I found one of the vulnerabilities that I found it by luck. It was one of the yeah, that's true, because I was having an incident, and I was searching. I have my PCAP running, and I found that there is a application called Parallel. I think you are familiar with it. I don't know if you are. It's Parallel, and this application
is that the VM thing on
yes,
macOS?
yes,
Yeah.
it is. So I found like it bugged me with. It wants an update. So the application wants an update. So every time a check for update is coming, and it just gives me a hell of a time. So after like checking my PCAPs, I found that it requests the update through an HTTP connection. It's interceptable for man-in-the-middle attack. So I was like, let me give it a shot, and I gave it a shot, and believe it or not, I was able to supply an update through Parallel using an unsecure connection, and I found this by total luck, because it was my PCAP or my Wireshark was up at that time. So yeah, sometimes luck will give you miracles.
Yeah. So I try to stay vigilant, like keeping an eye out for weird stuff happening on my computer, because it's a good source of tips for
Exactly.
where to look.
Exactly,
Yeah.
that's correct. So I want to Kevin here, or let me call Kev. So Kev, I want you to tell me the experience of your first bug. I know that you have a channel, YouTube channel. It's It's amazing. I will definitely share it and put it on the comment on the link below.
Thank you.
It's and guys, please check it out because it has a lot of
Yeah, I
awesome
think
videos.
it's not actually got my name on it yet. I don't have enough sort of people who've looked at it for it to be
No, but
allowed to be called the Kevin
it's the
Backhouse YouTube
content,
channel.
Kev. It's the content what we are looking for, man. So it's great. So I want you to tell me the experience and the story about your first bug and when was that?
So the first bug that I ever found was in Mac OS's kernel, which is called the XNU kernel. Um, and so there was this file called dtrace.c, and I was using CodeQL on it, and I had this CodeQL query looking for array accesses where the index of the array access might not have been bounds checked. And I found one that looked kind of suspicious. And so then this was my first time trying to write a proof of concept, and so it was a lot of work to create this proof of concept for this dtrace bug, because basically what dtrace is actually it's like an interpreter that runs inside the kernel, and it's used for things like tracing. There's a product called Instruments that I think it's called Instruments on Mac OS, that allows you to kind of insert tracing into the kernel, and under the hood it's using this dtrace thing. And so basically there's this kind of like format. It's almost like it's like a bytecode format, and so you can create a little program in this dtrace bytecode format. You can load it into the kernel, and then it gets executed in the kernel, which is obviously pretty dangerous to have a script language running inside the kernel. And so it took a long time to figure out how to get this formatting right, and I had no clue how to debug the kernel. So what I'd done was I'd grabbed snippets of code from the kernel source code in order to create a kind of a test harness where I could try and figure out how to make this stuff work. And so when I eventually actually triggered the bug, it was pretty amazing. I mean, it was the equivalent of a Windows blue screen of death. So it caused the computer to basically just stop, because there's like an out of bounds memory access in the kernel, and it just causes the whole computer to crash. So that was a pretty amazing moment, when the first time I ever managed to do that. In terms of severity, I mean, it wasn't a particularly interesting bug, and all I ever did was cause the kernel to crash. I didn't do anything interesting with it, like getting a privilege escalation or anything. But it was my first CVE, so I was very proud of it.
No,
It's pretty fun.
it's amazing because I think there is you cause the kernel panic, right?
That's right. Yeah.
Kernel panic. You in the interpreter, I think the interpreter there is an execute code in it. That's why.
Yeah.
Or
I mean,
you could
so I
execute
wasn't
code in
able
that
to get.
interpreter, yeah, and the dtrace.
Yes, I mean that's what it is. It's an interpreter, and it executes code, but it's kind of sandboxed. I mean, it's supposed to, although it executes code, it doesn't execute arbitrary code. So it's supposed to only allow you to do certain things, and you shouldn't be able to cause a kernel panic from dtrace code.
The
And
dtrace code.
it has a validator. So when you first load the dtrace code into the kernel, then it validates it to check that the code is valid before executing it. So the idea is that the validator should identify anything that might be not right, so that when you actually execute the code, that it won't cause anything to go wrong.
You know, and
But there was obviously a gap in that made this possible.
and usually I always say this is a theory that I have in mind, that finding a bug will give you an adrenaline rush that is much higher or 10 times higher than having a reverse shell.
Yeah.
So
Well, I don't know. That reverse shell probably feels pretty good as well.
yeah, but finding a vulnerability yourself, that will give you a 10-time adrenaline dose.
Yeah, it is a huge rush when you do find a new vulnerability. It's
Yes,
definitely
because
true.
you will realize that at the time that you were the only one who found it, because you will assume that you are the only one who found it. That's why it's available in the latest code or the latest version of the application, and there is no CVE discussing it. So you will think that you are the first one who discovered this. So I want
Yeah.
to
Although
move.
I guess
Yeah,
sometimes it turns out you weren't the first, but the other people
exactly.
who already knew about it were the bad guys.
Shh.
And that's when you've really actually made a difference, right? I mean, if and I'm pretty confident that some of the bugs that Mo has found in Chrome and Android fall into that category where some of the bad guys were in fact aware of it
They found it
until he
already.
disclosed it, and now one of their tools has been taken out of their arsenal.
That's to be honest, that's true because usually if you have really good findings that a finding that could give you a local privilege escalation or a remote code execution, that's something that actually works in a normal effort or a minimum effort. That sometimes the bad guys will use it to their advantage and they will not share it to the community, so they will not be able to fix it. That's great. But
Yeah.
usually, most of the time, researchers try to submit these vulnerabilities. But Kevin, now I want to move to the vulnerability or the bug that I really like, which is CVE 2021-3560.
This
This
is the
this
Polkit bug, right?
this is the ball kitty bug, yeah. So
Yeah, yeah.
this vulnerability, I remember when I saw it, because I don't remember. Just correct me here if I'm wrong. I remember when I saw this, I I saw like in the blogs, cybersecurity blogs, that there is something serious on Linux. Linux, there is a bug in Linux, and I was like, "What is this Linux bug?" And I checked it, and and there was no clear instruction because Kevin, you don't disclose things before things are fixed. So I didn't find instructions of how I can write the code. So I found it. I implemented the code I think 2 years ago, and I liked the simplicity of it, of calling privileged functions from unprivileged context. I like the function, and I like the idea about it. I know that it probably took a lot of time from you to find. So I want you to tell us more about this vulnerability.
Well, so I'm afraid to say this is another one that I found through a large amount of luck. Um, so what I was doing was I was looking at System D, and I was kind of looking at Polkit. So I was looking at code in System D that where it talks to Polkit to find out if you're allowed to do something. So there's this messaging system called DBoS, which is used for inter-process communication on Linux, and so you can use DBoS to send a request to systemd, and then depending on what it is, you might need to be kind of like root in order to be allowed to send that request. So systemd and other similar services, so there are a number of DBoS services that do a similar thing. They then check with Polkit. They send a message to Polkit to say, is this user allowed to do this action? And then Polkit checks its rules and sends back a reply saying either yes, they're allowed to do this, or no, they're not allowed to do this. So I was looking at systemd's code, trying to find some bugs, and I was working on something that was a long shot, turned out to be not like total failure, basically. I mean, I was trying to send millions of messages to systemd in an attempt to overflow a counter that was a 32-bit counter, and I didn't get anywhere close. I mean, I could get this counter up to about like 1,000 or something, like nowhere near to overflowing anything. But the weird thing is, and I was actually using a really innocuous thing. I was calling something called set wall message, which the security implications of being able to call set wall message when you're not allowed to, really, it wouldn't get you anything. But I was looking at that because it was simple. And so it was a way of studying the code with a simple example. But the weird thing is that I noticed that I was starting to actually successfully set the wall message. And I couldn't understand how that was happening because it should require root privileges to set the wall message. And so I couldn't understand how I'd managed to do this. And it turned out the reason I was able to do it is because my test program, which was sending millions of these messages, I'd run it for a while and then get bored and think, okay, this is not working. I'd basically kill that process with Control C. And it was the killing of the process that had this weird side effect that caused Polkit to actually approve the request. So once I realized that this was happening, that I was actually setting this wall message. I mean, obviously, initially I just assumed, well, this must be a bug in System D. And it wasn't a bug in System D. And the more I looked at it, the more I realized, actually, this is Polkit. Polkit is the one that is approving this request. So then I started looking at the code in Polkit to figure out what was going on. And that was when I realized that there was this sort of race condition bug where if you send a request and kill the calling process at just the right moment, then Polkit gets a little bit confused and it takes this error path where it then thinks that the calling process is actually a root-owned process, basically because there was a struct that was zero initialized, and so there was this field in the struct that contains the sort of the user ID of the calling process, and it was still zero at the point that you killed the calling process. And so now it thinks the calling process is owned by root, and so it approves the request because any request that comes from a root-owned process is automatically allowed. And so once I knew what the bug was, then it became possible to actually figure out a much easier way of triggering the bug. And that was what eventually led to something that could basically just be done on the command line. It wasn't 100% reliable, so you had to sort of often by hand do it like 10 times or something until it was successful. And then, I mean, you then came along and you sort of automated that, right? I mean, like you wrote a script that would sort of keep hammering it until it succeeded.
Yes, because when I was implementing that bug, because there was no clear instruction of how can I produce it, and I was like, I have this problem that sometimes when I try to write a script or write exploit code, I have this problem that in my mind, I feel like this Ubuntu version or this Linux version is updated. And I feel like I'm not going to produce it, and I have to check it once again to check that I'm on, because if there is no clear instructions of the things that I should do, and there is a bug and I'm waiting for the clear or the full disclosure, so I will be like I will be asking myself, am I in the right Linux distribution, or am I having the right controls? Should I try multiple times? Because sometimes at the beginning of your research, you will be you will be shooting in the dark. You will be testing some things, and sometimes it will not work or not succeed in the first attempt. So you'll think that your work is not going anywhere. So when I was doing your vulnerability, and I tried to find the race condition so I can execute my code in the right time, I was like, if I'm doing this now, how Kev managed to find it in the first place? Like, you got the idea. So finding it is something. If trying to reproduce and with minimum instructions, I'm trying to understand, I'm hammering it in the hope that I'm getting something in return. But you finding it and find it with no instructions and with luck, this is something amazing. So kudos, Kevin, on this one. I like it. So I like it so much. So what about, so that's regarding the Polkit exploit. What about, or vulnerability? What about your last CVE, which is libssh? Can you tell us more about that?
The libssh one. So, I mean, I don't know how serious the libssh vulnerability was in practice, but when I found that bug, I was like, this is the only chance I'm ever going to get a remote exploit of an SSH implementation. So I gotta make this work if I can. And that's this one. I'm pleased to say I did actually find, not by luck, but by reading the code and noticing that there was a bug in the code. So what I was doing is I was looking at the code that checks that the signature is correct. So when you're authenticating with SSH, you need to use your private key to sign a blob of data, and then the server checks that the signature is correct. And in that code, one of the things that happens is it uses some code from OpenSSL, from the OpenSSL library. And I noticed that there was an error path where if the OpenSSL library was to return null, then it would actually approve the request. So you could send an invalid signature and it would still say, yes, this is okay, because it took an error path where it would say that this was actually okay. The difficulty was that in order to trigger the bug, you had to cause an out-of-memory error in the OpenSSL library. That was the only way to trigger this bug. So I guess the thing that was interesting to me about this, and what made it an interesting challenge, is it possible to trigger an out-of-memory bug that's sufficiently precise? So basically, I mean, I needed it to... This was something where it was trying to allocate a really small amount of memory, 50 bytes or something like that. And so in order to hit that target, I mean, that's a really tiny target.
And you are talking about remote attacker, right?
Yeah. So I mean, but in order to trigger it for the out of memory condition to happen at exactly the right moment in exactly the right part of the code seemed like an almost impossible task, and I was absolutely not sure that it was going to be possible. And the test setup that I used, I mean, libssh is a library, so there's no kind of standard application that you can use as a target. So what I did was I took they have a demo server application in the repository. So I used the demo server as a target. And what I did was I set an artificial memory limit on it. So I said I used ulimit, the ulimit command, to set the memory limit to a quarter of a gigabyte. And that's the bit where this is a slightly, possibly unrealistic vulnerability, because I think it's only exploitable if somebody would... Pardon?
As an attacker, you will not be. So I don't know how as an attacker you will be triggered because it's out of memory. So trigger like giving like 50 or I think 70 this part or 50 this part you will not be able to produce it by remote code, or you cannot fill the memory with that amount unless you just repeatedly calling it.
So what I found was I found a way of generating a massive amount of memory pressure. So I found that there was a different thing that I could do that caused... Basically, I'd send a bunch of messages to the server and then not reply to those messages. And what would happen was the send buffer on the server would fill up. And also SSH has a compression mode where you can send data with zlib compression. So you can send a relatively small package that actually expands to quite a large amount of data on the server side. And then there was this particular message. It was called the service request message that you could send. And it would reply back with the same message that you just sent. And so I could create a massive amount of memory pressure on the server by sending these compressed messages, which would decompress on the server side and then get backed up in the send queue on the server side. So the send queue would get full with lots and lots of data. And so that could cause it to use up a huge amount of memory. But what I've found with out-of-memory errors is that on 64-bit machines, what tends to happen is if you use up all the memory of the machine, then rather than anything erroring out, the thing just kind of grinds to a halt. And so the only way that this becomes exploitable is when somebody's put an artificial limit on the amount of memory the application can use, which may be plausible. I'm not sure. I mean, if somebody is running libssh in a Docker container, for example, they may have decided to run that Docker container with a memory limit on it, so that, I mean, this is like an internet facing service, and so for security reasons you might want to as a precaution, make sure that nobody can cause a denial of service by causing a massive amount of memory allocation. And so you might, as a precaution against that, put an artificial limit on the amount of memory that your container can use. And so if somebody had got that set up, if somebody is running libssh in a memory constrained container, then this is a potentially exploitable vulnerability.
But finding this bug was great because you looked at line by line having this vulnerability, which is
I was definitely on this occasion. I was
something out of
definitely stepping through.
yeah.
I was stepping through that authentication code line by line, studying it really hard because it's such an important piece of code to do that authentication.
You know, the problem is sometimes when people look at codes or protocols that already been there for ages, and me personally, I do look at these protocols because I know that hundreds and thousands of researchers have researched it thoroughly, and they didn't nothing found yet. Nothing found yet, like publicly. So sometimes I feel like these protocols is out of vulnerabilities, bulletproof, because of even the vulnerabilities you will be finding, it will not be significant that will cause disruptions. So this is my view about these ancient protocols, if you say. But yeah.
It's true. I mean, that's one of the keys to success in security research is just not assuming that something must be secure because other people have looked at it before you. I mean, it's often not the case.
Yes, that's correct.
There are still bugs there.
Exactly.
I mean, there was one not that long ago where somebody found a bug, an exploitable bug in sudo. You know, the application,
the sudo edit?
sudo. You know the program on Linux called sudo, sudo?
Yeah. Sudo edit.
Somebody found a bug in that allowed you to exploit sudo. I mean, that just blew my mind that there were still bugs in that thing. I mean, because that thing must have been audited to death by now. You'd think that so many people must have gone through that application line by line, and yet there's still a bug in it.
I don't know if you are referring to the sudo edit. There was one.
That's one. Yeah,
the sudo edit. That bug was also great because it's sudo, something that was ancient application that were running for years.
It's amazing that still has a bug in it. Yeah, absolutely amazing.
So, Kev, so what are the tips and tricks of finding security vulnerabilities? We said we check manual code or manual audits, and we do fuzzing. It's luck. It's things you read line by line. You go to the GitHub code or something, and you can download it and try to cause the application to halt or to misconfigure it. So what is the tips and tricks for people to use so they can quicken their research?
I mean, so you mentioned quite a few of them already. So like fuzzing and static analysis and auditing the code, making sure you understand it really clearly. I guess the other one I'd say is maybe some security areas I think are crowded. So there's a lot of people looking at Chrome, for example. And so not saying that all the bugs have been found by any stretch of the imagination. I mean, there's definitely still bugs in Chrome, but it's a really high bar. You're going to have to find bugs in Chrome. You're going to have to spend a lot of time studying it first, and it's probably going to be at least 6 months, maybe a year before you have enough knowledge about that thing to be able to start finding bugs in it. So I guess my recommendation is to try and look for things that maybe haven't been looked at quite so much. And that's part of the reason why I spent time looking at DBoS, because I figured that it was maybe a less heavily researched area, but if you can find a bug in it, it's still really high value, because there's a lot of processes that are running as root that have a DBoS interface to them. And so there's a lot of potential there for privilege escalation vulnerabilities. And I mean, I guess another example would be cryptography of a very, very heavily researched area where not to say that all the bugs have been found or all the problems have been found, but I mean, you're going to have to invest an awful lot of time in order to find new bugs in that area. So that's why I try to seek out things where I think maybe they haven't been looked at quite so much, but they're still high value if you can find a bug in them.
And I think there is bug bounty programs could be used.
Yes, yeah, of course. Yeah, bug. I mean, that's off limits for us. I mean, so GitHub Security Lab, we only do open source security. So we don't ever look for bugs in proprietary applications. But for most people,
It could
going
help.
through bug bounty programs is a really good way of getting into security research.
Okay, what about if I'm open source maintainer of open source maintainer? I want to ensure the security of my code or my project. What can I do to improve that?
So one of the big ones is just have a security.md in your repository. So I think you can get security researchers to help you out. I mean, if you actually invite them to sort of talk to you and tell you about vulnerabilities that are in your code, then you can have a good relationship with security researchers. And so the first thing you need to do is create a security.md, which tells them how to report stuff to you. So you could have an email address in there, for example, but also make it clear what the scope is. I mean, sometimes if you don't tell people, then people might not realize that certain things you really don't consider to be security vulnerabilities. And so making it clear what is a security vulnerability and what isn't in your security.md will help you to get high quality reports. I mean, like a really obvious example of that would be bugs that are on your main branch. If they haven't been released yet, if you don't have it in a released version, then it's not a security bug, and you just want to receive that as a regular GitHub issue rather than as a security report. That would be a simple example of the kind of thing that would be out of scope for being treated as a security vulnerability. And then also we have this thing called private vulnerability reporting, which is something you can just switch on in your GitHub. If you go to the security tab and poke around in the security tab, then you can switch on private vulnerability reporting, and that will allow people to confidentially report security vulnerabilities to you very easily. And then that actually becomes a draft security advisory. So you can seamlessly then convert that into a security advisory, request a CVE from our team, and then once the bug is fixed, you can then publish that security advisory. So those are two simple things that you can do that will really help. And then there's also some other kind of like free things that you can do very easily. So I mean, you can switch on code scanning. That's also just like a few button clicks in the GitHub UI. Using GitHub Actions to run tests, automate the running of your tests will help a lot. And then I think that code coverage is really valuable. So there's a company called CodeCov, which their stuff is provided for free. So if you have an open source project, you can enroll it in CodeCov. And I reckon that code coverage is actually one of the most important things for making sure that your code is secure, because if you've got code that's not covered, then chances are it's got a lot of bugs in it. And so just by running a code coverage tool and just making sure that all of the important parts of your application have code coverage is really going to help to reduce the number of security vulnerabilities that you might have. If you're a bigger I mean, there's this thing called OSS Fuzz, which is really an amazing system. So this is a Google thing.
Sorry, it was what?
OSS Fuzz. It's made by Google, and it's basically a free fuzzing service. You do need to be a somewhat sort of notable open source repository. So I mean, they don't accept kind of anybody's like hobby project. It needs to have a sort of a significant number of users, but it's really a really amazing service. So basically what you have to do is you have to provide you have to provide the integration so that they can run the fuzzer on your project. But then once you've set up that integration, then they use their data centers to run their run fuzzers on your project. And so, I mean, I'm a maintainer of a project called Exif2, and we've enrolled Exif2 into OSS Fuzz, and so it's getting continuously fuzzed by Google, and they're just doing this for free, and it's really an amazing thing. And it often, like, if somebody does make a mistake when they check something in that is like a buffer overflow or something like that, typically OSS Fuzz finds it within a day or two. It's really quite impressive how well it works.
Okay, so doing the scanning by Google is something is great, but sadly, unfortunately, we cannot, as a normal project, you cannot just submit your project in there. That's the
That's true.
downside
Although,
to
I
it.
mean,
That's the downside to it.
yeah, I mean, on Exif2, we, as well as OSS Fuzz, we also have a GitHub action that runs fuzzing, but we've time limited it, so it only runs for 2 minutes. Because if you let it run for too long, then you'll use up your quota and get cut off.
Yeah.
But even that is actually still valuable, and often catches things during the sort of checks phase. So when somebody posts a pull request that they want to have merged into the Exif2 project, then one of the checks that runs is this 2 minutes of fuzzing, and sometimes that's enough to
Find what you're looking for.
catch a bug. Yeah.
Yeah.
But I mean, you can also then run that same thing, because I mean the configuration is there, and so it's relatively easy to do something like renting an Azure or an
Server.
AWS server, and just run the fuzzing yourself for like a few days or something, and typically that would be enough to find any new problems.
Okay. So we covered in this episode, Kevin, we covered things that happened in the past CVE, in the all CVEs, and we covered the methodologies and things we can do to find vulnerabilities. So assuming that if I'm Ahmed and I found the vulnerability, what should I do from there? Should I immediately submit it like for Twitter, or should I immediately write about it, or what should I do? So because if you are like, if you found a vulnerability, you'll be rushing it, and you will be afraid that someone else will find it before you, and
Yeah.
your credit will be stolen. So what is your thought about if you found a vulnerability today? And you just found it, everything is nothing there yet, so you just immediately rush to Twitter to write about, or LinkedIn, or you inform the company? What is the best case scenario, if you may, to report a bug?
I mean, you should, hopefully they've published something like a security.md, which will give you guidance on how to report. I mean, if it's a private company, then there's a chance that they have a bug bounty program, and you can submit it to them through the bug bounty program. And if it's an open source project, then with a bit of luck, they've got a security MD, or they've got private vulnerability reporting enabled. And so hopefully that will make it easy, and you can then submit it to them. But I mean, it definitely happens a lot that we find vulnerabilities and we can't find any contact details at all for the project. And so then, I mean, we do our best. So I mean, one thing you can do is you can look at the Git history of the project, and the Git history actually has email addresses in it. It's one of the features of Git, is that it does have email addresses attached to commits. And so sometimes you can look at the Git log and figure out who are the right people to email. But to be honest, we've often not had great success with reporting vulnerabilities that way. I mean, you send off the email and nobody replies. We've had better success with creating an issue on the project that doesn't disclose the vulnerability, but just says, we found a vulnerability, please contact us. And that still, the success rate is probably still less than 50%, we found with a lot of the time. but that's still better than just putting
Nothing.
it on Twitter.
Yeah. Usually, people, for example, if I found something today, I will try to email the company or put it on the GitHub maintainer and try or what's open source maintainer, and then I'll try to give them like 3 months, and then I'll just publish it. People are doing that. It's not
Yeah,
right
so
or
it's a
wrong.
good idea to have a
Yeah,
policy about how long you will wait before you disclose. And so we have a policy that says 90 days.
3 months. Yeah,
And if you don't have a policy of your own, you could always just reuse somebody else's. I mean, you could just include a link to say we use the same policy as GitHub
policy too.
Security Labs policy, for example, and that would
Yeah.
be fine
That will be
for you to
sufficient
do.
for so you
Yeah,
can be able to publish it on Twitter with no restrictions, or you
yeah,
can at
and
least
because I mean,
write a.
ultimately, if the it you can't keep this secret forever, right? I mean, if you've tried as best as you can to report this to somebody and you
Reach out to
just
them. Yeah,
I mean, at some stage it's important that the users of the project know that there's a problem,
yeah,
right? And if you've done your best to try and disclose it and you've had no success, then ultimately the users do still need to know, which is why we have the 90-day deadline. And that's
policy.
kind of a 90 days seems to be kind of an industry standard. So like Google Project Zero have the same
Some period.
kind
Yes.
of policy. Yeah.
Okay. Thank you. With that, I want to thank you, Kev, for being here in the show. I
Yeah, thank you
think.
very much. Thanks for
Thank
inviting
you.
me.
You're most welcome. We really enjoyed it, and I'll be leaving your YouTube channel and the link below. And please, guys, check out his videos. He doesn't post much, but what he publishes is something that you should look for. So thank you, Kevin, for being here, and thank you guys for sticking to the end of this episode. Please share your comments if you have any, either in the comments section below, or you can send directly to Kevin or me. We will be happy to answer your questions. And if you have anything in mind, please share it. We love to hear your opinion. And please share this episode with anyone you think is interested in vulnerability research or finding bugs. I think you will be having a blast. Please even repeat this episode. Sometimes replay it. When you hear it for one time, for the first time, you will not get all the things we talked about, but playing it for the second time will give you the context much better. So thank you guys for being here, and I'll be seeing you in the next episode. Thank you, Kev.
Thank you.